So good day class, today we're going to talk about the magnetic properties of our materials. So the magnetic property, this is the response of a material to an applied magnetic field. Before we talk about the magnetic property though, we have to understand what a magnetic dipole is. So when you align a magnet with another magnet, ang nangyayari is may tendency na mag-shift yung position ng magnet ay relative to that other magnet. Because that magnet tends to align with the magnetic lines of force of the external magnetic field. And yung alignment na to, this is dictated by the magnetic dipole of that magnetic material. And our magnetic dipole moment aligns from south to north na magnetic field lines. So essentially, yan lang yung direction ng magnet natin, yung magnetic dipole mo. So now let's look at some magnetic properties. So we have your magnetic field strength, your magnetic induction or magnetic flux density, the permeability, the magnetization of a material, and the magnetic susceptibility of our material. First, we have magnetic field strength H. This measures the amount of magnetizing force that your material is exposed to. Ang units natin usually dyan is amps per meter. Related to that, we have our magnetic flux density V. And this is the amount of magnetic force induced on the given body due to an external magnetic field. Related ang magnetic induction or magnetic flux density natin with your magnetic field strength by the proportionality constant mu, where mu is your magnetic permeability. The magnetic permeability, this is the ability of a material to support the formation of a magnetic field within itself. So pag expose siya to an external magnetic field, magnetic permeability tells you how strong the induced magnetic force in your material will be. So our magnetic permeability, this is usually referenced against vacuum, which has a permeability of 4 pi times 10 to the negative 7 henries per meter. So going back to our magnetic flux density B, B is equal to mu H. So we usually reference mu with respect to mu naught or the magnetic induction of vacuum. So we get a value, mu r. This mu r is your relative permeability. And this is just yung permeability ng material mo over the permeability of vacuum. Next, we have the magnetization of our solid M. So when a magnetic material is placed near a magnet, the moments, the dipoles inside your material will tend to align with your magnetic field, which will cause an increase in the flux density of our material. This increase in our material or our magnetic reinforcement is related to your magnetization of the solid. Since yung magnetization natin M, this is just parang yung amount na nadadagdag na magnetic field strength sa material natin when exposed to an external magnetic field. And lastly, we have your magnetic susceptibility. So the magnetic susceptibility, this just indicates whether a material is attracted or repelled by a magnetic field. So basically yan yung kung lalapit ba siya or medyo marirepel in the presence of magnetic field lines. So your magnetic susceptibility chi, this is just your relative permeability minus 1. So a positive value means that it would be attracted by a magnetic field, and a negative value would mean that it is repelled by our magnetic field. So magnetic moments in our materials originate from the movement of electrically charged particles. It is kind of like how a solenoid with a passing current or a wire with a passing current has a magnetic field going around that wire or solenoid. So in this case, for our materials, the movement of our electrons is what supplies the magnetic property or the magnetic moments of the said material. So the electron motion that is possible is the spin of the electron about its own axis and also the orbiting of the electron about the nucleus. So the electrons are in their orbitals and constantly gumagalaw yan. So these two phenomena would give rise to the magnetic moments inside our material. So for the spin magnetic moment, this is the spin up or spin down of your electron. Or meron din tayo ng orbital magnetic moment natin. This is now the spin or the movement of your electron around or about its orbital probability cloud. So by combining the magnetic moment contributions of the orbital motion of electron and the spin of the electron, we get the total magnetic moment of our material. So we can represent our magnetic moments as a vector na may directions. And since ganito, pwede silang mag-cancel out if opposite yung directions ng moment nila. And by totaling all of the moments inside your material, mag-iiba yung magnetic properties ng material mo. So one application is for our noble gases. So noble gases mo, yung orbital moments and spin moments cancel out, making the magnetic property of your noble gases weak. They become not capable of permanent magnetization. So now let's look at the different types of magnetism possible for our materials. We're considering 5. In this case, we have diamagnetism, paramagnetism, ferromagnetism, antiferromagnetism, and ferrimagnetism. Una, meron tayong diamagnetism. Pag diamagnetic yung material mo, there is zero net magnetic moment because the spin of the electron at up and down are the same number. So they cancel out and you have zero net magnetic moment for that material. So diamagnetic substances are actually slightly repelled by a magnetic field. This would mean that negative yung magnetic susceptibility ng material mo. So take for example, you have a magnetic field going this way. If you have a material na ganyan, na diamagnetic, makita natin the magnetic moment of your material will align in the opposite direction, which would lead to the slight repulsion of that material with our magnet. So examples of diamagnetic materials are your aluminum oxide, alumina, copper, and gold. So these usually have even number of valence electrons in their structure. So one particularly exciting application of our diamagnetism is in magnetic levitation. So in magnetic levitation, you have a very diamagnetic material exposed to a magnet. Due to the repulsion, mangyari is magle-levitate siya off that magnet. So this is really important in applications where you don't want friction in between two bodies. So para yung mga high-speed trains and maglevs and so on. So next we have paramagnetism. So paramagnetism, a paramagnetic substance have magnetic dipoles associated with each atom. But yung magnetic dipoles natin dito, they are randomly oriented, which makes your material not magnetic. But when placed near a magnet, your dipoles will tend to align themselves with your external field, making paramagnetic materials have a positive magnetic susceptibility. So this is your magnetic field. Your magnetic moments aligned with your magnetic field. So paramagnetic materials are actually slightly attracted by a magnetic field. So you have examples like aluminum, chromium, and manganese sulfate. Next, we have ferromagnetism. So ferromagnetism is similar to paramagnetism in which your material has magnetic dipoles, but ferromagnetism is more magnetic than paramagnetic materials since the moments in our material is aligned, even in the absence of a magnetic field. So yung ferromagnetic materials mo, yan yung conventional na mga magnets natin. So examples niyan is your iron, cobalt, and nickel. So most of our magnets actually is based off of these elements. So an interesting thing about ferromagnetic materials is that when you increase the temperature of that material by supplying enough heat to that material, the alignment of your magnetic dipoles actually become loose or mawawala na yung alignment nila, turning them into a paramagnetic material. So this happens at a temperature in which we call the Curie temperature. Above the Curie temperature, your ferromagnetic material actually turns into a paramagnetic material. This can be seen by looking at your magnetic susceptibility versus temperature graph here. So lower temperatures, at lower temperatures, your material is still ferromagnetic. But as it passes through the Curie point, bumababa na yung kanyang magnetic susceptibility na nagiging paramagnetic na yung behavior niya. So next we have your antiferromagnetism. So antiferromagnetism is similar to ferromagnetism in that the magnetic moments are highly aligned. But in this case, yung magnetic moments natin, kahit aligned sila, opposite yung direction sila, such that magka-cancel out lahat ng magnetic moments mo. So parang nagiging non-magnetic na yung material mo. So examples is manganese oxide, manganese sulfide, and iron oxide. So antiferromagnetic materials can also turn into paramagnetic materials upon the application of heat, since heat just randomizes the direction of our magnetic dipoles. And this happens above the temperature which we call the Mill point. And lastly, we have ferrimagnetism. So ferrimagnetism has highly aligned magnetic dipoles, similar to antiferromagnetism, opposite yung direction sila. But in this case, hindi na equal yung amount of, let's say, up and down magnetic moments, which makes these types of materials have high magnetic strength, similar to your ferromagnets. So ito yung tinatawag natin na yung colloquially na magnetic materials. Ito pa yung ibang klase ng material na pwede natin gawin na magnet. So examples ito is your magnetite and pyrrhotite. So yung magnetite natin yan yung pinakaunang magnet talaga na meron tayo. Na na-discover natin, I mean. So to end this module, we'll look at the magnetic hysteresis curve of our materials. So sa magnetic hysteresis, we're just plotting the external magnetic field H versus either the magnetic flux density or the magnetization of our material. So this tells you how receptive your material is to an external magnetic field. So to construct this curve, we usually induce or we expose the material to a magnetic field in one direction, then we reverse that to the other direction, and back to, then is-cycle natin siya until we get this one. So one important thing that we can get from the magnetic hysteresis curve is the efficiency in which your material can retain the magnetization induced by an external magnetic field, even if the external field is taken away from it. So makita natin yung magnetization na matitira sa material mo when the external field is now at 0. So we can read the magnetization na natitira. So if this value is close to the saturation na magnetization ng material mo, this would mean that your material retains your magnetism very well. But if hindi ganun siya kataas, if kunyari, nandito lang siya, konti lang yung magnetization na natitira when you remove your external magnetic field, which means your magnet is not effective in retaining its magnetization. So depending on the hysteresis behavior of your material, you can actually classify it into what we call your hard and soft magnets. So hard magnets, these are materials that retain its magnetization effectively. So ito yung mga permanent magnets natin, and this is important in applications such as speakers, hard drives, and electric motors. Meanwhile, yung mga soft magnets natin, ito yung mga materials that do not retain its magnetization when your magnetic field is removed. And this is important in applications such as transformers, since yung energy loss in this case is maliit lang. And with that, we end our lecture for today. So thank you, God bless, and hope you are all keeping sane and safe.